So on pages 3 and 4 of your set theory and logic notes, we are going to start talking about subsets. Oftentimes, a collection doesn't contain all of the elements in a set. For example, let's say a museum has 2 Picasso paintings. While these 2 paintings are a set, they are just a portion of all Picasso paintings. We can say that a set of these 2 paintings are a subset of the larger set of all Picasso paintings. So let's formalize this a bit. Set A is a subset of set B if every element of set A is an element of set B. So as far as the notation goes, it looks like this. So subset A does not have to contain all the elements of set B, but it may. If sets have the same elements, they are called equal sets. And we will need this definition of equal sets later when we talk about proper subsets. So every set is a subset of itself. And the empty set is a subset of any set. Okay, let's look at this example. I have elements listed in set A, B, and C. And when I ask these questions, order will matter when I ask them. So when I say, is A a subset of B, I'm asking, is every element in set A also in set B? So perhaps you see that that is a problem because not every element in set A is found in set B. I see 0 is in set B, but 3 is not in set B, so that would be a no. But if I turn that around, if I ask you, is set B a subset of set A? Well, I believe our answer is going to be yes, because is 0 found in set A? Yes. How about 6? Yes. How about 12? Yes. So B is a subset of set A. Is A a subset of set A? Well, is every element listed in set A in set A? Yes. And remember we had said that every set is a subset of itself. Is the empty set a subset of B? Well, yes, we said the empty set is a subset of every set, and that would be including itself. Now, when I ask, is B equal to C, I'm asking, do they have the same elements, the same identical elements? Well, let's see. We have 0, 6, and 12, so that looks like yes. Is set A equal to set C? Well, no. I do have a 12, and I have a 6 and a 0, but A has many more distinct elements, so that would be a no. A proper subset is a subset that does not contain every element of the original set. So it contains fewer elements than the original set. So if A is a proper subset of B, here is our symbol for that. Now you'll notice I don't have the line underneath it, so that means I'm not including the equal set. So that's the meaning of that particular notation. If set A is equal to set B, then set A cannot be a proper subset of set B. So a set cannot be a proper subset of itself. Well, why? The sets are equal. A set is going to be equal to itself, right? And the empty set is a proper subset of every set except for itself? Well, the reason for that is they can't be equal, right? So let's pause this video, and I want you to try the following examples here, and let's see how you do. Okay, so A cannot be a proper subset of itself. We already have that established. B, however, is a proper subset of A because it's a subset and they're not equal. So C and B are equal, so C cannot be a proper subset of B. Empty set is a subset of every set except for itself, so that's a yes on D. And since empty set can't be a subset of itself, that's a no for E.